Hello there, welcome to this video. This is the second video on solving trigonometric equations for our lesson for AP Precalculus of part 1 on solving trig equations. We're going to go ahead and wrap up this lesson, and before I go ahead and continue any further, I want to revisit a problem in my last video that I left out an answer. Shame on me. And it had to do with our second solution here in solving the trigonometric equation after we took out a GCF of 2 sine x. On the equation over here, the 2 sine x equals 0, sine x equals 0, that occurs at two locations. Your y value is 0 at the North Pole and the South Pole. So I just want to make an adjustment here also. I'll add this answer in blue. That x is also equal to pi plus 2 pi k. And if you were smarter than me, you could rewrite both of these. Both of these could be encompassed by the answer x equals 0 just plus pi k, where k is an integer, because that would cover both of these situations. Okay? All right, so without further ado, we're going to go ahead and jump into the last couple of examples that we have here. And these examples are really going to kind of tap into, at least the first one is tap into your knowledge of reciprocal identities. We're going to go ahead and rewrite. If we're ever posed with an equation where we have cosecant or secant, we must rewrite these in terms of sine and cosine to utilize our knowledge of the unit circle. So we're going to go ahead, and let me actually make this full screen, maybe you can see better. We're going to go ahead and look at this example. So they say here the function g is given by g theta equals secant theta plus the square root of 2. For what values of theta on the interval pi to 2 pi inclusively is g of theta equal to 0? Okay, so they want to know where is g of theta equal to 0. So g of theta is secant theta plus the square root of 2 equal to 0. So we're going to go ahead and we're going to subtract the square root of 2, move this over to the other side, and we get secant theta, that's supposed to be secant, my brain's going ahead, secant theta is equal to negative square root of 2. Now I don't have any information in the unit circle on secant theta, unless you've memorized values of secant theta, which congratulations on that, because that's an impressive feat. But secant theta, I'm just going to rewrite this in terms of cosine so I can access my unit circle. And cosine theta, remember, is the reciprocal of secant. So I'm just going to take the reciprocal over here of this. And this may not look familiar, but if we go ahead and rationalize this, if I multiply top and bottom by square root of 2, we get negative square root of 2 over 2. And that should look very, very familiar. So your x value is negative root 2 over 2 in quadrants 2 and 3. So we have theta is equal to 3 pi fourths, that's quadrant 2, and in quadrant 3, 5 pi fourths. Now we do have a domain restriction. We have a domain restriction that they give here, or I guess a range restriction. Well, I guess technically it's a domain restriction for our input. But they're saying, hey, your answer must live in this range between pi and 2 pi. So they're saying in the southern hemisphere, right? So from quadrant 3 to the end of quadrant 4. So what we're going to do, we're going to remove 3 pi over 4, and our answer, is strictly 5 pi over 4. Pretty easy. Okay, I want you to go ahead and look at this practice problem. Please pause me and try this example, and I'll go over the solution here in a moment. Okay, in this example, they say the function g is g of theta equals 4 sine theta. For what values of theta on the interval pi halves inclusive to 3 pi halves inclusive is g of theta equal to 2. So we're going to go ahead and we're going to take g theta for sine theta, set it equal to 2. We'll go ahead and solve, divide both sides by 4, and we get sine theta is equal to 2/4, which reduces to 1/2. And we want our y value to be equal to 1/2. So this happens at pi 6, and it also happens at 7 pi over 6, no, 5 pi over 6, where our y value is positive. Okay, so these are the two locations, and we want the answer to be between pi halves to 3 pi halves. So we throw out pi 6, that's in quadrant 1, and we're just going to keep 5 pi 6. So that's all it is. Not too shabby. Okay, let's look at the last example that I have for you, and on these next two examples, I have some issues with the questions, so we're just going to make some corrections to these problems. Really quickly, make an adjustment here. Add a vertical line to that negative. Let's make that a positive 12. And then down here for this 15, go ahead and take your white out. I don't know if I have, do I have white? I don't know if I, where's my white? Oh, shucks. We'll go yellow. We'll see if we can get rid of that 1. We're just going to make it a 5 pi for this practice problem down here, okay? Just so these problems work. Okay, let's look at this example. Let's look at this example. And it has to do with domain restrictions and range restrictions with arc cosine, because otherwise they don't equal each other, okay? So anyway, the function z is given by 12 arc cosine of x. Solve for z of x equals 8 pi for values of x in the domain of z. Okay, so my z of x function, I want to set z of x equal to 8 pi. Now z of x is 12 arc cosine, and I just want to write it in its alternate form so you're familiar with it. Cosine inverse. And we want to go ahead and solve this. So we'll isolate our cosine inverse by dividing both sides by 12. So we have 8 pi over 12. And thus here this reduces 8 pi over 12. We can reduce by 4. We get 2 pi thirds. So cosine inverse of what value gives us 2 pi thirds. Now you can go ahead, you can rewrite this, right? X is equal to cosine of 2 pi thirds. If I want to undo this cosine inverse, I can just take cosine of each side, okay? And essentially, we're saying, hey, what's the x value at 2 pi thirds? At 2 pi thirds, and the x value would be a negative 1/2. X is equal to negative 1/2. There you go. Not too difficult. Okay. Practice problem. Please pause this one. Please try this one. Again, make sure you took off the 1 on that 15 pi. Otherwise, the problem doesn't work for the range values of sine inverse. Try this one, and I'll show you the solution here in a moment. Okay, so p of x equal to 5 pi. That is 10 sine inverse of x equal to 5 pi. We'll go ahead and divide by 10, and we get sine inverse of x is equal to 5 pi over 10, which equals pi halves. Okay, so we want to know what x value, or what value is produced by a sine of pi halves. Okay, and this would give us x is equal to 1. And there you go. Okay. So we just went over a couple of other problems solving with trigonometric equations and using our knowledge of the unit circle in order to solve these equations. Okay, so not too different than what we did in the unit circle unit. Those were expressions. These are just equations. So we kind of have to move a couple of more things around. All right. Give me a thumbs up, like the video, subscribe, follow Rad Math Dad on TikTok if it's not banned yet. Catch you later.